welcome to the Explainer. Look, today we're doing more than just writing code. We're going to build a safety plan for it. It's all about moving past, hey, it works, to, hey, this thing is built to last.
All right, let's kick things off with a scene that I'm sure every BTech student knows by heart. You've been coding for hours, right? You're convinced your code is perfect. You hit compile, you hit run, and bam! It just breaks. Your console lights up with that wall of angry red text.
But here's the kicker. That crash, it isn't necessarily a flaw in your logic. Nope. A lot of the time, it's just some unexpected event. You know, like trying to divide a number by 0. You can think of it like a sudden earthquake that hits at runtime, and it's threatening to bring your whole carefully built program tumbling down. All right, so here's the plan. We're going to talk about what makes Codebreak Java's safety net, the anatomy of these accidents, how to plan for them, and finally, how to raise the alarm yourself. Let's jump in.
First up, code that breaks. Let's really nail down what we're up against here.
So, in the world of Java, these runtime earthquakes have a name. They're called exceptions. An exception is pretty much any event that messes up the normal, happy flow of your program. And if you don't have a plan for it, well, your application just dies. Game over.
Okay, so how do we deal with this? Well, thankfully, Java gives us a powerful safety net, a whole set of tools for building resilient code.
The first tool in our kit is the try block. The easiest way to think about this is as your monitored zone. It's where you put any code you know is a little sketchy. You know, stuff like trying to open a file that might not be there or doing some kind of tricky calculation. So what happens if something does go wrong inside that monitored zone? Well, that's where the catch block comes in. It's your emergency response team. It jumps into action, catches that specific exception, and runs your backup plan, stopping the whole program from going down in flames. And then there's the finally block. Think of this as your site cleanup crew. And the best part is it always runs. It doesn't matter if there was an exception or if everything went perfectly smoothly, the code inside finally is guaranteed to execute. This is absolutely critical for tasks like closing a file or a database connection, you know, the stuff you have to do no matter what. So let's put it all together. The flow is super predictable, and that's what makes it so powerful. You try the risky stuff. If something blows up, you catch the problem. And no matter what, you finally do the cleanup. This simple structure, it's literally the foundation of building safe, professional Java code. All right, we've got our tools. Now let's talk about the anatomy of the accident itself. We need to understand the different kinds of problems we might face because, trust me, not all exceptions are the same. Okay, so at the very top of the hierarchy, we have the throwable class. Everything that can go wrong at runtime is a child of this. And it has two main kids you absolutely have to know about: error and exception. So what's the difference? Well, errors are the big, catastrophic stuff. Things your app has no control over, like the JVM itself running out of memory. It's like the foundation of your building just crumbles. There's no recovering from that. Exceptions, on the other hand, are the things your program can and should plan for. You know, a user enters bad data or a file you need is missing. These are manageable.
Okay, let's keep going. We're going to zoom in on that exception category because it's split into two really important types that you need to understand. And this is where it gets really interesting. Java splits exceptions into two camps: checked and unchecked. Checked exceptions are the ones the compiler literally forces you to deal with. It's like, hey, you're working with a file? That file might not exist. You have to have a plan for that. It won't even compile your code otherwise. Unchecked exceptions, also called runtime exceptions, are usually your own fault. Things like a null pointer exception because you forgot to initialize something. Handling them is optional. And you know, this is a pretty hot debate among Java developers. Some say checked exceptions make code safer. Others say it just adds a bunch of extra typing. Knowing the difference helps you decide what kind of architect you want to be.
All right, last section. We've talked about handling problems. Now let's talk about raising the alarm ourselves. How can we signal and declare risks in our own code? First up is the throw keyword. This is you manually pulling the fire alarm. When you're inside a method and you detect a problem, maybe the input is invalid, you can literally throw a new exception. This stops everything in its tracks and signals that something has gone very wrong. Now, don't get that confused with the throws keyword. This isn't about pulling the alarm. It's about putting a warning sign on the door of your method. You add it to the method's signature to say, hey, just a heads up, this method might throw a certain type of exception. It's a warning to any other part of the code that wants to use it, telling it to be ready. So what's the big takeaway here? Look,
Exception handling isn't just about cleaning up messes or fixing bugs. It's about design. It's a core part of being a software architect. Honestly, getting good at this is what elevates you from just being a coder to being a real engineer who builds robust systems.
So you have to ask yourself, are you just writing code or are you building an architecture? Because this framework, the safety plan we just talked about, that's your key to building programs that don't just work when everything's perfect. It's how you build software that can actually survive out there in the real messy world.